All right, this is worksheet H for probability chapter, Venn diagrams. There's three examples on this assignment, three problems. A university professor historically fails 20% of his students on the final. After the final, he polls the students and asks them how many of them studied for more than 3 hours. Of those who passed the final, 72% said they studied for it. Of those who failed, 31% said they studied. Make a tree diagram. So, the first branch is going to be if they passed or failed. That's why I'm going to do it. So, this branch will be that they passed. This branch will be that they failed. Okay? And I'm going to put probabilities with each one. So, along this branch, how many pass? So he fails 20%. Okay, so this branch is 20% of his kids. So then in every tree diagram, when you have a split, the split has to account for everybody, all of his students. So this has to be 80% because 80 plus 20 is 100%. So anytime you have a split, the two probabilities must add up to 100. Okay? All right, so of the kids that passed, we're going to have another split, right? Of the kids that passed, what do we know about them? Of those who passed, oh, there we go. 72% said they studied. Okay, so that leads me to think that my two branches here are studied and let's do this, did not study, the not equal to sign, okay? And what are the probabilities there? Of the ones that passed, 72% said they studied. Okay, so this would be 0.72. So here's a branch again. So this entire group, either they studied or they didn't, right? So then the not study group would be 28% because 0.72 plus 0.28 is 100 or 1.0. Okay. Then on the bottom, we're going to do the similar thing. Of the kids that failed, some of them studied, and some of them did not study. And you read down here, says it right here. Of those who failed, 31% said they studied. Okay, so this is 0.31, which would mean this is 0.69. Adding up to, again, this adds up to 1.0. Okay, it's all filled out. Now we can answer the questions. What is the probability that a student studies? So there are four routes through this tree diagram. You can get here, 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 or here. How many of those routes did the student study? That happened in this route and in this route. So I want to find the probabilities of these two outcomes, like right here and right here. The probability of this route is a back-to-back event, right? You studied 0.72%, 72% of the time, and then you pass the test. You multiply these, so the likelihood of this branch occurring is about 57% of the time. We could do this for every branch, actually, and it'll probably help us. So 0.80 times 0.28 would be this branch right here. We're not really looking at this one right now, but I just thought I'd put it in there for kicks. Then this branch is 0.20, 0.2 times 0.31. So only 6%, 0.062. So what does that mean? This is for all of his students. 6% of them studied, but they failed. So not many. And the bottom route would be you failed and you didn't study. So 0.20 times 0.69, 0.69. So that's 0.138. Here's a quick little check, right? These are the kids that failed, so if you add these up, it should be 20%. And I think it is, right? 0.062 plus 0.138, 20%. So it does work out, okay? And if you add these up, you get 80% kids that passed. All right, so how many students studied? Well, that would be the two yellow branches. These kids studied and they passed. These kids studied and they failed. So we add those up. 0.576 plus 0.062 is 0.638. 0.576 plus 0.062. So looks like only about 2/3 of his kids studied. Doesn't study. Well, you could do all the work and you could add this plus this. That's one way to do it, like this. Or you could take 1.0 minus this, because you either studied or you didn't study. And you should get the same answer either way. Voila! And you sure do. So that's 0.362. All right, now we're getting into conditions for both of these. C, if a student studies, he passes. All right. Probability of passing given he studies. We'll do ST, right? The condition is you studied. The if is the condition. So I'll highlight that in yellow. Okay. In a tree diagram, it's much easier to do with the formula. Okay. And if you recall, the formula is the probability, the numerator is the probability of this and this happening. So passing and ST, studying. And the denominator is the probability of the condition, which is studying. We have a lot of these answers in above, right? So the probability of the numerator, you passed and you studied, that's this route. So that's 0.576. The denominator, we also have the probability that you studied. We found that right here. So 0.638. So let the formula guide you, because this gets very confusing if you're trying to rationally think through this. So the answer is 0.902, about 90%. So in other words, this is what the professor would tell his students. Hey, look, guys, 90% of my students that study pass. So if you want to study, or you want to pass, you should study. All right. And on the flip side, what's the probability that if you studied, you failed? We'll say F, given you studied. Well, logically, let's try to take a shortcut. Aren't these two things complementary? They have the same condition. The same condition is studying. If you study, you either pass or you fail. Fail right there. So 90% of the time you pass. So wouldn't it be logical that if you did 1.0 minus your answer right here, that would be the probability of failing if you studied? So we're going to get that answer right there, 0.097. And if you understand that, great, move on, you're done. If you'd rather go back and do the formula every time, be my guest, be my guest. But you don't need to. But I'll show you the steps again. Here's how you would set it up. Okay. And we have these probabilities. So the numerator is failing and studying. So that's right here, 0.062, divided by the probability that you studied, which we found right over here again, 0.638. And seeing is believing, so let's divide those. And boom, 0.09, look at that, just like I said, 0.097, okay? If you understand the idea of a complement, that these two events, these two answers are complements, then you only need to find one and then subtract the other from 100%. And likewise, these are complementary. So this time I'm going to take the short way out. I'm going to find this one using the formula, then I'm just going to subtract from 1 for that one. All right, formula would be probability you fail given you, how did I write this? In the diagram I put did not study. How's that? Did not ST, did not study. This would be the probability. It's a fraction. Probability of failing and not studying over the probability of not studying. All right. The numerator we have in the tree diagram, failing and not studying. That's this route. Failing, not studying is happening 0.138 as a probability over the probability of not studying, which we have right here, 0.362. And let's see what we get. 38% of the time. Okay. So that's the answer there. Now, let me change color so it stands out. So E and F, part E and F are complements. Okay? If one of them has to occur. So the answer is just 1 minus 0.38. So you're going to get 0.62. Okay. 2. This one's about commuting times. When you get older and you're driving to work every day, the same route every day, you're going to try to save time and get home quickly. Hopefully you don't get road rage. All right, when you're traveling home, there are 2 routes, the city streets or the freeway. If I take the city streets, I will definitely get home in less than an hour. Okay? If I take the highway, there's an 80% chance I'll get home in less than an hour. But if it's jammed up, it will take much longer. I take the highway 3 days out of 5. Okay. What are my 2 main branches? I think my branches are going to be city streets and highway. We'll say city, streets, and highway. Highway, okay? Now, what is the split? Remember, every time you split, it has got to be 100%. It said, I take the highway 3 days out of 5. 3 divided by 5, so that's 0.60. So this is 0.60, and then you take the city streets, 0.40. Okay? Then what does it say? If I take the city streets, I will definitely get home in less than an hour. Definitely means always, right? Which means 100%. So I'm just going to say, I guess there's really only kind of one branch off of here. And this, I'm going to label this as less than 1 hour. And it's 100% or 1.0. It happens every time when you take the city streets. If you take the highway, it's more of a gamble. I'm assuming, all right, so when there's traffic, you're not getting home in less than an hour. Sometimes you'll get home in less than 1 hour, and other times it will be more than an hour, greater than 1 hour. What is the split there? If I take the highway, there's an 80% chance I'll get home in less than an hour. Okay, so that would be here, less than an hour, which means this greater than an hour is 0.20. Maybe you're thinking, well, why wouldn't you just always take the city streets? Well, I'm guessing like the city streets are maybe like 40 minutes, but the highway, when it works, is less than an hour, but it's maybe like 30 minutes. It saves you time. All right, let's get the probabilities off of each branch here. Remember these three by multiplying through. So this times this. Well, that I can do in my head. 0.40 times 1, that's 0.40. 0.60 times 0.80, I can probably do that in my head. 6 times 8 is 48. So I think this is going to be 0.48. And then 6 times 12. Sorry, I said the answer. 6 times 2 is 12. So 0.12. If you add these up, you get 100%. If you don't believe me, check it. Right? Good. Because one of these three things must happen. I didn't say that up here, but again, if you added up all four of these, it's 100%. Okay? It covers all the possible things that can happen. So, part A. What's the probability I get home in less than an hour? Okay, well, that would be this branch plus this branch. That looks like 0.40 plus 0.48, so 88% of the time. B, it's got an if, so this is a condition. If I get home in less than an hour, what's the probability I took the highway? So highway given less than 1 hour. Okay, the if is the condition. Okay, using our formula, the numerator will be the probability of taking the highway and getting home in less than an hour. The denominator is the probability of the condition, probability of getting home in less than 1 hour. And we have those in the chart. Well, we have them. What's the probability of the highway and less than an hour? That's the highway and less than an hour. That's right here. So this is this probability. And this we found over here, less than an hour. So I already kind of have my two answers, folks, and I just need to know where to look. So it's 0.48 over 0.88, and what do I have? So 0.54 repeating, looks like 54% of the time, if I get home in less than an hour, it means I took the highway. All right, last one. More about the test. Just different probabilities. People that studied, I should say. I take a true-false test, I study for it, and I feel, well, I estimate that I have a 90% chance of knowing the answer. So it's a little bit different. And if I know it, thus, I will get it correct. On the questions I don't know, I will guess. Okay, what does that mean? Guessing is a 50-50 proposition. Okay, make a tree diagram. All right, so what are my two main branches? My two main branches are the first part. It said, I estimate I have a 90% chance of knowing the answer. Okay, so I know it or I don't know. IDK, okay, I don't know. And this person's pretty confident. They're like, yeah, I know 90% of the stuff, which means they don't know 10% of the stuff. Okay? If you know it right here, then what happens? Thus, you will get it correct. Boop. There's only one bar branch off of here, and that leads to a correct answer 100% of the time. 1.0. Okay? If you don't know it off of here, you might, well, it says you're just going to guess. You're going to get it correct sometimes, you're going to get it incorrect I'll just say wrong other times. Okay, and this is the I will guess part. It's a 50-50 proposition. So half the time in this scenario, you get it right, and half the time you get it wrong. So what are my three probabilities? Because there's only three different branches here. The first one I'm doing in my head, what's 0.90 times 1? Well, that's 0.90. And then the next two are both 0.1 times 0.5, which is 0.05. Okay, so there's three different scenarios for this student. Part A, what's the probability they answer the question correctly? Well, that would be this plus this, 90 plus 5, so 95% of the time. B, if I answer the question correct, it's because I knew it. Okay, so remember, if this is the condition, okay? So the probability I knew it, so I know it, given what condition, it was correct. I can't spell. Correct. Correct. Okay. And the formula again is the numerator. It's the probability of knowing it, and being correct over the probability, the denominator, of the condition, which is being correct. I think I have all of these already. I just got to pick the right ones, right? So, um, I've got know it and correct. That is know it and correct. That's right here, 90%. Over the probability I got it correct. And I did that here in part A. That's 95. Some of you are pretty good with your proportional reasoning, so that's pretty much 95%, but it's a little bit lower. 947. All right, part C, it's just a different condition. So if I guess, that's my condition, I get the problem correct. So correct, given I guessed. Remember, that's the condition. So that would be the probability of correct and guessing divided by the condition of guessing. So equals numerator, I already have. Correct and guessing is here. I don't know. That's when you guess, right? Maybe I should put right here. They're gonna guess, right? They guessed and they got it right. So that's right here. That's 5% of the time. Out of, what's the probability of guessing? Well, really, this is, you guess here and here. You guess 10% of the time. So, I mean, I guess that's pretty logical. That's a half, right? If you're going to guess, what's the probability you're going to get it right? Sometimes logic, I mean, I just did all that and I'm like, why did I do all that, right? If you guess, it's a coin toss. It's a 50-50 shot. I didn't need to do all that work. Man, oh man. Sometimes. All right.